Hey, g'day guys, welcome back to another statics slash dynamics video. And before I work on a problem, I just want to explain forces. So forces fall under the vector category. So a vector is something that needs a direction and a magnitude or an amount. A very typical coordinate system that we would use. So this is considered the y or the j direction, which is vertical, and the horizontal direction is considered the x direction. And it's important to note the signs here, that the right side on the x-axis is positive, the left side is negative, up on the y-axis is positive, and down on the y-axis is negative. If we wanted to solve for these forces x and y, assuming that this particle, the center, is in equilibrium, meaning that it's static, it's not moving, all we have to do is set up very basic equations. In fact, it's actually Newton's second law. So for the y direction, we know that the force in the upward direction is positive, so we write down 5. And then we know y newtons works in the negative direction, so it has to be minus y. And we've been told that this particle is static, so the resultant force on this particle is 0 in all directions. So it must be 0. And then we plus y to both sides, and we get y has to be equal to 5 newtons. And now we have to do the exact same for the x direction. So 13 newtons works in the positive direction, so it's plus 13, so we just write 13. And then x newtons works in the negative direction, so we write minus x newtons. And once again, this particle is not moving in any direction, whether it's horizontal or vertical, so the horizontal component must also equal 0. So then we plus x to both sides, and you get x must be equal to 13 newtons. For the acceleration of the system of an Atwood machine. So an Atwood machine is just basically a single pulley with two masses attached to it. And the first thing to do is realize that the Atwood machine is going to go in favor of the heavier mass. So we're going to call this direction positive. So first we focus on the 10 kilogram mass. First, we have to notice that the tension in the string is going to be equal. So the tension on the left hand side equals the tension on the right hand side, and that's a force. And the weight force of the 10 kilogram mass is just its mass times gravity, so it's 10g. Now we write an equation for the 10 kilogram mass using Newton's second law, which is the sum of the forces is equal to the net force. So since this direction is positive, we know that 10g works, the weight force works in the positive direction. So 10g minus t has to be equal to the mass times its acceleration. Now for the 5 kilogram mass, we know that it's going to have a weight force, and the weight force is equal to its mass in kilograms, times G. So the weight force acts in the negative direction and the tension acts in the positive direction. So it's tension minus 5G is going to be equal to 5A. And now this is just, now we have two equations with two variables, so that means we can solve. So we'll bring T minus 5G is equal to 5A. So we want the T's to cancel so we can solve for A, the acceleration. So the way we do that is if they're opposite, if they're opposite signs you plus, and if they're the same signs you minus. So they're opposite here, so you just plus. So the positive T and the negative T will cancel. 10G plus negative 5G equals positive 5G is equal to, and then 10A plus 5A is equal to 15A. Or the acceleration of the system is equal to G on 3. Now if we wanted to solve for the tension in the string, just substitute the value of A into either the first or the second equation.